Hello students, good evening. Hope you are fine there at your home. Now today, as I wrote to you on the WhatsApp, that I will give you a video message for sieve analysis as well as this liquid limit experiment, in which we have a semi-log graph. So to construct a semi-log graph is new for you, so that's why I thought that you should know how to plot this uh, semi-log graph. For this I have already draw some data and some theoretical things onto this whiteboard. I will explain it to you. First, this in sieve analysis you have to plot the curve, that is S curve, between the cumulative percent finer and the particle size, or in this case the sieve size in millimeters. So first of all you should know that what is the percent finer. Percent finer is the percentage, that may be 10%, 20%, 30% to 60% or 30% by weight, which is finer than the size of the particle corresponding to the curve. Means if you have this curve, this is percent finer, this is sieve analysis. Now the percent finer means that from the curve, this 30% finer means that the corresponding to the curve, this diameter or the size of the particle, this size of the particle has 30% particles of that soil is less than that particular diameter. Means that in this figure D30 means that 0.2 millimeter diameter is से जो छोटे पार्टिकल हैं वो 30% है. Means according to this curve that 30% by weight of the total soil is less than the diameter of 0.2 millimeters. That is percent finer. Now we have this example, a small example of data which is for these three observations, so that you can calculate the cumulative, how to calculate this cumulative percent finer. So first of as you have already done in the laboratory, in the soil mechanics lab, you have those students who perform the sieve analysis test already know that you have the different sizes of the sieve. The on the topmost side, there is a bigger particle size sieve, and under that the smaller one, and so on, and on the last there is a pen. So if these are the sieve sizes 0.6, 0.5, 0.425, and this is the weight of retain on that particular sieve, total weight of the soil is 500 gram, so this is total 500 gram. So how to calculate this weight retain in terms of cumulative percent? You have to calculate first percent weight retain, that is 40, that is 200 is the weight retain, 200 divided by total weight 500 into 100, that this is equal to the 40%, that is percent weight retain. Similarly this 50 and 10, say in the same manner. Now cumulative percent retain means 40 is written same as 40, then 40 plus 50 is 90, then 90 plus 10 is 100, and so on. अगर और भी हैं तो you have to calculate all the values. Now the cumulative percent finer is 100 minus that cumulative percent retain. Cumulative percent finer means cumulative percent retain को अगर आप 100 में से minus कर देंगे, you will get this cumulative percent finer. So in this 100 minus 40 is 60, 100 minus 90 is 10, 100 minus 100 is 0. So in this way you have with you the percent finer, cumulative percent finer. You are advised to go through the example in the books, or whatever you perform in the laboratory experiment, solve the solve the problem by taking observation table from that laboratory observation, or I have given 2 or 3 problems in the notes which I have already given to you. You can draw if you have the semi-log graph. If you don't, then if you can arrange from the stationery, you can have this, you can draw this by this method. Now, what is this logarithmic variation and what is arithmetic variation, or simple graph and logarithmic graph? So arithmetic variation means all the parts are of equal in nature. 1 2 3 4 5 6 7 8 9 10 means 1 centimeter is divided into 10 parts, so one part is equal to 0.1 centimeters, and so on. So you can draw the graph by simple equally spaced squares. Now the logarithmic variation is somewhat different than the arithmetic variation. This part is divided into 10 parts as it divided into 10 parts in arithmetic variation, but the parts are not of equal in nature. It is first part is bigger, is the largest one, and the second part is somewhat shorter than the first part, and so on, keep on decreasing. The last part, that is 9 to 10, is the smallest part between the 1 to 10. So this is the variation of the log variation. So for drawing this logarithmic variation, you have to have the each cycle of 10 divisions is equal to, it may be 0.1, 0.1 to 1, or 1 to 10, 10 to 100, 10 to 100 to 1000, like this. It is 10 to the power n, where n is plus minus 0, 1, 2, 3. So if n is equal to 0, it means it is 1. So if n is equal to 1, it is 10. If n is equal to 2, it is 100. If n is equal to 3, it is 1000, and so on. If n is equal to minus 1, it is 0.1. If n is equal to minus 2, it is 0.01. If it is 0.01, if it is minus 2, it is 0.001. If it is minus 3, it is 0.0003001. So this is the variation, that is 1, 10, 100, 1000. 1, 0.1, 0.01, 0.001, 0.0001. So this is the one cycle comprises of this variation. If we are lying in this cycle, it means each particle is of 1, 2, 3, 4, 5. If we are in this cycle, each division is of 10, 20, 30, 40, 50, 60. If we are in this cycle, each division is of 200, 300, 400, 500, and 600. If we are in this cycle, it is 0.2, 0.3, 0.4, and 0.5. If we are in this cycle, we are 0.01, 0.02, 0.03, 0.03, 4, 5, 6, like this, and so on. So here, if we have this cumulative percent finer versus particle size, so first of all we have to find out the limits of the graph. For limits of the graph, we have this percent finer, which is obviously 0 to 100%. So it is in the arithmetic variation. So it is simply 10 equal parts, or which may be 2 parts, 2 centimeters equal to uh, 10% or 1 centimeter is equal to 10%, whatever you uh, desire suitable as per your requirement and as per your problem. Now this variation of this logarithmic variation is, first of all, you have to find out the